Thanks. Nice to meet you here. Yeah, so as Carolina said, I will be talking about modular games in Unity, and would like to say something about me. So I am a professional programmer since 2011. Mostly I did some IT stuff, but since 5 years I'm working in game dev. And last 3 years I'm part of the more PG Evil Lands game team. We developed this multiplayer online RPG game. And I will also mention that my first 5 years I spent developing something called Enterprise Web Application, which was, well, many people can say it was kind of a monolith poop, which will result later why. Basically, if you follow the trends of IT, the general IT stuff, you can notice that the last 2 decades it was pretty turbulent. There was a big hype on microservices, which for last few years just fell apart because people realized that those microservices have their own flaws, so they are not as scalable in smaller teams and have some overhead of management, of managing such services. So this resulted in something called modular monoliths. And these modular monoliths are kind of monoliths that incorporate all the stuff that microservices have well done. Why I'm talking about that to you, to game developers? Well, basically because Unity is kind of monolith. If you take any random definition of monolithic architecture, you will probably see something like that, that this is a single binary file or binary application that concerns multiple business stuff. And every major update of such application requires deployment of a new version of the binary. So basically, if we know that in the IT industry, we have some great features, some great evolution of monoliths to something like modular monoliths, how can we take the good stuff into our games architecture? I would like to start with some brief overview about Unity projects. Basically, if you start new project, you will probably see something like that. We will have some custom classes, some custom behaviors, and maybe some editor scripts that are based on Unity engine stuff and maybe some system libraries. If our project grows, you will add probably some new modules in form of libraries or some Unity packages, maybe NuGet packages. All those stuff we can, let's say, put into the second layer of our application. When our project is more mature, if we tend to create some other application that shares common logic, we may introduce a third layer, which will contain some shared logic, logic that can be shared between projects, like, I don't know, some RPG features, like progression system, maybe quest system, some tutorial stuff, analytics, all those kinds of things can be put in this third layer. So basically, at this point, we can see that our architecture tends to look like the standard monolithic application called layered architecture, which is in smaller projects, it may be enough, but in bigger projects, you usually end up with something like this picture. Well, basically, why does it happen? Because 90% of our games are basically still in those two chunks. And we have to be honest, games are pretty complex. The logic of games is pretty complex in terms of, for example, comparing to a simple IT application, right? You have many complex performance-related tasks and other stuff that is not easy to just put in a simple block of logic. Games are also pretty uncertain. They have dynamic requirements. We can introduce new feature, and after a month we decide that we don't want to evolve anymore because it just didn't pass the test. The players don't want it, so we just get rid of it, right? And if we have big teams, we can have some maybe not experienced programmers, maybe some lazy programmers that don't know all the patterns that can solve our main problems. Yeah, so how can we use the modular concepts to organize our game engine, the core part of our game? I would like to show you this on a case study. Let's pretend that we have some game engine really bad written, and it has a lot of cyclic dependencies that are hard to untie. And you would like to introduce something called blacksmith feature. So we would like to introduce this guy that will repair our stuff for some gold. And the one more thing, we would like to make this blacksmith feature independent. So we would like to move this feature into our second game if it passed the tests, right? So in order to do that, I propose to split our classes into 3 groups. We can start with model classes, which are basically the classes that store the data, some settings of our feature. The controller group is part of where we store classes connected to the main logic of the game. So for example, in this case, it will be taking gold from the player and repairing stuff. And the third part, the view part, it takes all classes that are responsible for representing the game state to the view, to the user, mainly in terms of view. So some pop-ups, some labels, gold labels, and so on. So if we start with the data, we will see it's pretty simple. We can have just the blacksmith current gold property. We also have some basic blacksmith config with some starting max gold and the list of pricing entries. So if we want to repair legendary sword, it will be much more expensive than fixing, I don't know, some epic helmet or something like that. But I said that we would like to keep it in a separate module. So if we create something like blacksmith assembly, we will have our first conflict because item rarity and item kind, these are 2 enums that belong to the game engine part, the spaghetti part. So we can represent it like in this graph. So basically, we would like to get rid of this red dependency from items to blacksmith. And this is pretty easy. We can just introduce a new assembly definition called items model and put those 2 classes into it. So our dependency graph will be a little bit healthier. Note that those 2 enums, it's pretty easy to just move them out. And we would like to introduce such changes to the engine that don't break its already existing logic, right? We don't want to reintroduce some regressions. We don't want to refactor half of the project. So in terms of model, that's enough. Let's say it's fine for us. Let's move to the controller, the most problematic part. So basically, let's say we have this try repair method that just gets the price of the repairing item, and it tries to spend the gold. It tries to get the gold from the player, and after that, it will add the same amount of gold to the merchant, and it will also, of course, adjust the item, so it will adjust its durability to fix it. So the first problem in this class, or in this method, is that it also depends on item data. And we could do the same trick like we did with enums, but for the sake of some experience, some exercise, let's say that this item data has some really badly written dependencies that we don't want to move. Let's say it depends on some gameplay state or something, and we don't want to touch this class. What can we do? Basically, we can do something pretty easy. We can just create some twin sister. So this will be the repair item data class, which is pretty similar. It will contain all the stuff that we need for our blacksmith to work, but also it will live in a blacksmith assembly definition. So we don't have this dependency to the game engine. We can simply replace the item data occurrence in our try repair method. And thanks to that, when we want to use this blacksmith feature somewhere in the game engine code, we'll just have we just have to map our item data to the twin sister class, the repair item data, right? In this case, I just used some simple constructor, but in most complex cases, you can introduce some mapper class. This is also a great pattern to use in more complex cases. Our dependency graph doesn't change a lot because we just introduced a new class in blacksmith module and some mapper, maybe some mapper in the game engine. So it stays the same, let's say. Okay, let's check another method, the adjust durability one. So we would like to access the durability of our item data class. And we could just introduce this into our system, our twin sister, the repair item data class. But we have no guarantee that it will be passed by reference. So we may change it and just forget about this change in next couple of lines of code. And we have also no guarantee that our change to the durability will invoke all the triggers that are needed on the game engine side. So for example, if we adjust our item's durability, we want to refresh the progress bar of our item, right, on the display. And we want this guarantee to happen, right? So how can we solve that issue? We can introduce item fixer interface. It will live in the blacksmith module because it's related tightly to the blacksmith feature. And simply we can implement this interface in our items controller, which is on the game side, right? So we have this proper dependency from blacksmith to game engine. The main problem here is that if we think in a modular way, we stumble upon another cyclic dependency because we wanted our blacksmith model, the blacksmith model to be independent, but now we introduce the dependency from blacksmith to the items because items have to implement the interface that lives in blacksmith assembly definition file. So we can just do a quick fix for this. we can introduce some blacksmith repair adapter, which will also live in game engine. But this class will, let's say, glue together both different and separate modules. So if we have our items assembly definition and our blacksmith assembly definition, this class will glue them in just a few simple lines, because it will just implement this interface and it just needs to get the item from the items module and do the stuff it would normally do in this module. So our dependency graph changes a little bit. Right now you can see that blacksmith and the adapter depend on our items module. Okay, the next method from try repair main method is the spend player gold. And this method is problematic because of our dependency to player RPG controller. Let's say it's the class that is responsible for spending player gold. In such case, we can introduce another interface, let's say currencies controller. It looks pretty similar to the previous item fixer, but in this case, we would like this interface to be in a separate module, because our intuition tells us that this currencies controller is something totally separate, and basically it's a good candidate for another module responsible for all the stuff connected with currencies. But for now, we can just implement this iCurrencies controller in our RPG controller, which is pretty easy because this class already contained those methods. So we just need to extend its signature. And at the blacksmith level, we replace the dependency from RPG controller to currencies controller. So now our dependency graph looks like this one. Basically, we have this separate module that is base for both the blacksmith and the player RPG. Another issue connected with spend player gold method is the dependency to the pop-up stuff. Basically, we can, again, do something similar to our first trick with item kind and item rarity enums. So we could just take those two classes connected with pop-up system, let's say this error pop-up data and pop-up data, and again we could move it to another assembly definition like with currencies. So it will be pop-up assembly definition. But this again violates some laws of modular development. Well, mainly because pop-ups is something that should live within a view environment. And right now, we just did the thing that our blacksmith controller is depending on some pop-up data, some view-related stuff. And this breaks the general MVC rule. So in this case, if you would like, for example, to construct our environment, for example, if we use dependency injection, we would like to install our blacksmith in some game logic context, while our pop-ups should live in some view context. And basically, the rule is that view context depends on logic context, not vice versa. So we just introduced some burden for our blacksmith module. And basically, we could live with it, but it's really problematic in case, for example, of sharing this stuff with different projects, different games. In this case, if we would like to put our blacksmith module into our second game, we don't have guarantee that the pop-up system made in this game is, let's say, it may result in conflicts because the the second pop-up system may not depend on the pop-up data and error pop-up data which we require right now, right? So it's better way to resolve such case. We can just introduce the event. We can just call the repair failed in place where we call the pop-up controller show pop-up. So in this case, on the game engine side, we have to introduce something like blacksmith pop-ups handler, which is pretty simple. It just needs to listen for this repair failed event. And when it gets it, it just does what the blacksmith method did before, right? It just shows this pop-up. But with such approach, we have this more healthier relationship between those classes because our controller now is the main part and view just depends on it. It's the proper way of those dependencies. And the last one, the add merchant gold method, is complicated because of two things. We would like to have this blacksmith config taken from some point of our system, right? But let's say we have already some game config controller that manages stuff like other configs, for example, items config, maybe some RPG config. And this game config controller is responsible for A/B testing, maybe some cloud features. It just downloads the data from the cloud and applies to our application logic. And we would like to keep those features, right? Because they are pretty complex and also pretty useful. Same story with blacksmith data. We would like to store this data probably in some common file, maybe some JSON. Maybe we would like to encrypt the result, our JSON result, and move to the cloud. So also we would like to keep those functionalities. So how can we solve this dependency with saving controller, game config controller? Basically, again, introducing interfaces. We can provide blacksmith config provider, which will be implemented in game config controller. And same story with blacksmith data provider. It can be implemented in save controller. Both those classes can use blacksmith data, blacksmith configs, because the dependency is this way. And our blacksmith controller now is, again, independent. It can be moved to different project, which does not have a game config controller or save controller, or have totally different implementations of those stuff, right? So in this case, our dependency graph is pretty simple. We just need to provide those containers to the parts that belong rely on them. So in this case, game config controller and save controller. Okay, the worst part is off, so we can move to the view one. So basically, when I'm talking about view, I'm mainly talking about observer pattern. Why? Basically because it solves about 70% of your view-related issues, right? So there are also some other common patterns like fin state machine or some composite decorator, but these are, well, they are used in more complex cases and more specific cases. The main majority of issues connected with views can be just reduced by using those observer patterns. So if we go back to our try repair method, we can already spot some places where we use it. We, for example, can notify our system about change in gold. We can just put the event gold updated, and in any class that is responsible for or is interested in those changes of gold, it can just listen to this event and react properly. In this case, we can just update our blacksmith gold label by the proper amount of gold, right? And It's worth to mention that this pattern is not relevant only to the strict view. It's a pretty nice solution for all the consumers that we have in our application. For example, if we have some analytics or reporting system, these are mainly consumers, right? They just take data, digest it, and maybe process it and send to the cloud. But basically, they don't return any result or stuff. So they can be called, let's say, consumers, and they can just follow the same observer pattern. Same story with adjust durability. If we want to notify our system that the item was fixed, we can just put the event item fixed, and maybe in our game we can have some notification system that already works for different notifications. We can just reuse it by simply adding this adapter called blacksmith notification handler. And you can also see the similarity between a blacksmith notification handler and the blacksmith pop-ups handler that I showed you before. It's exactly the same story, right? You have the same pattern. And this is also great way to make your architecture more readable, because if you follow the same pattern in, like I said, 70% of places, or the view places, it will be readable, it will be clear how it should work and how to do this in another features that we would like to incorporate in the future, right? So this was pretty complex stuff, so I would like to do some quick summary about it. Basically, if you want to solve the coupling problems in your applications, these are the main methods that how you can do that. So you can just move data containers into separate modules. Usually data containers are great candidates for that because they don't have dependencies to other parts of our system. You can use interfaces to communicate with other modules, like I did with the item fixer. The same story with currencies controller, right? The third one, observer pattern, and the fourth one, MVC pattern, they always go together. If you want to follow the MVC principle, you will usually use the observer pattern a lot. So this is a great way to avoid the dependency cycles between a controller and a view parts of our system. And the last one, the use game side adapters, we did it when we want to when we want to glue some not related modules, like for example this blacksmith and items. They were modules that we don't have a strict relationship. We cannot say that blacksmith is something that should depend on items and vice versa, right? In such cases, adapters are a great way to solve or to join those different features together. They usually will live in the game engine part. So it's also worth to consider how we can manage those adapters stuff in our game engine. Maybe they should have some specific namespace or some folder where we want to keep them all. So if we want, for example, to move our blacksmith module to another game, we also can consider just copy-pasting those adapters that belong to our game engine and use them in a second game. Of course, there will be some conflicts to solve, but they are generally really mild ones compared to such pretty tightly bound module like in spaghetti code, let's say. Okay, so regarding benefits, I hope that you already noticed some. Basically, using such independent modules just separates concerns a lot. We can to be honest, we can just take the blacksmith module itself and create a separate scene in Unity for it, and just create some mock files for those missing interfaces like currencies controller, items fixer, and we can have separate scene for that. We can test it separately without involvement of our game core, and it should work like a charm, right? Reusability is just the same. We can move this module to another project without bigger conflicts. In testability, such classes that are written using some basic stuff like those interfaces that we have to implement, they are pretty easy to mock. We can easily create some integration tests without, again, reusing stuff that is already spaghetti. And flexibility is, let's say, the same, because if we want to extend our module, we can follow the same rules, the same patterns like we did before, and it just should work. Okay, the last part that I would like to talk about is some modular concepts that don't fit to the case study, but are also really important. So I would like to take a few words about them. So let's start with layers and modules. Basically, it's kind of this dilemma: how do you slice the tomato? Well, in a game architecture, it's kind of both. We have benefits, and we can do both together. We have benefits from both separation of concerns. So in this graph from my private projects, you can see that we have yellow lines, which are those modular dependencies across the project. And you have these green lines, which are those dependencies that stem from using MVC pattern. So if you follow those rules like MVC pattern and those modular concepts, you can just have this nice graph where you start on the bottom right and just go to the bottom left and go to the top right of your application. You will have this nice graph with no dependencies, right? Few words about assemblies. Assemblies are great in terms of preventing us from doing bad stuff. If we would like to introduce some cycle between two different assemblies or a few different assemblies, it doesn't have to be one-on-one. It can be a loop between different modules. We will get the compilation error. We are forced to fix it because our game just won't compile. So this is great, especially in bigger projects where you have a team of some experienced and unexperienced game developers. They are strictly bound to not introduce some bad patterns to your code. The second great thing about assemblies is hiding some internal stuff that we don't want to use in some other modules. Some critical performance related or maybe some security related stuff. I will show you on this blacksmith controller because it's already familiar. So if we have the blacksmith inventory controller that is responsible for managing inventory, and we have this contract between blacksmith controller and blacksmith inventory controller in terms of this public inventory method. Well, so let's say that this public keyword doesn't fit here. We don't like it, but we're kind of forced to use it because our blacksmith controller cannot access this method in other case, right? So basically, assembly is something that works fine with internal keyword. If we try to use this inventory method somewhere outside of this blacksmith assembly, we will get again some compilation error. But this may raise some concerns because we want to test our applications. So we introduced this init method because it was convenient to put some chunk of logic that is pretty independent from this blacksmith controller. And we want to test it easily, right? As I said before, modular development tends to ease our workflow, not to harden it. So in this case, there is a solution. We can just put the assembly info file, which has this internal visible to keyword. This stuff allows you to test your internal stuff in blacksmith tests assembly without any issues. Okay, the last part, the formality levels. Well, basically I said a lot about assembly definitions, and you may say that, okay, we should use assembly definitions then. But it's not exactly true. If you do some new projects, especially if you're prototyping, you probably would stick to this folder namespace formality level. For modules that are immature or are pretty good candidates to change in the future, it may be not worth to invest much time to make them properly. You can just try to stick to your folder, yeah, but you don't have this rigid restrictions like in assemblies. Yeah, assemblies. These are pretty fine for more mature projects, for more stable features. You can give those boundaries that developers cannot just breach. And they are also fine for hiding some critical stuff, like I said, with this internal keyword. Submodules, well, technically, they may be used without assemblies, but this is pretty risky because without assemblies, it's easy to introduce some logic that does not belong to the submodule. So if you want to reuse the submodule somewhere else, you may have some compilation errors that you are forced to solve with rewriting the submodule itself. But submodules are also great tool if you have some separate teams, dedicated teams, like you may have some core team that works on the core of your game. You can have some tools team, some assets team. If it's possible, it's great to use the great tool to diversify the workflow. So those teams can work parallel on their dedicated submodules, and they won't introduce any conflicts in your repository. And the main con connected with submodules is that they are pretty technical. So if you have a team of non-technical users, it's maybe more convenient for you to use the packages formality level. It's, let's say, the most user-friendly because you have just to fetch some packages from package manager, which is more user-friendly in terms of interface and stuff. But on the other hand, it's also the most time-consuming stuff. You have to put some maintenance effort. You have to keep those README, changelog files. You have to provide some installers if you have some assets within this package. So it may be cumbersome, but still worth to consider if you have non-technical stuff. Basically, that would be all that I would have to say. I have some tips that will summarize my talk. So basically, I really strongly recommend to use the MVC pattern. It's great to use those observer state machine patterns that support this MVC. And as I showed you with this case study, interfaces are a great tool for decoupling the cyclic dependencies, some hard to untie dependencies in your project. And regarding writing tests, the writing test is not only connected with catching bugs or preventing us from regressions. Writing tests is also a great tool to check our architecture, because if you have some hard to set up tests, it may be some indicator that you have something wrong with your architecture. That maybe this class has too many dependencies, maybe it has too many responsibilities. So it's also a great way for testing our architecture in just straight away, just at the moment when you start writing your tests. In terms of architecture, I suggest to start small, starting with the folders formality level. Then when your project matures, you can go on, introduce the assemblies, maybe submodules. It's also depending on the project, right? For me, it's pretty important to encapsulate shared modules because this is something that this is something that makes those submodules pretty safe, and it's harder to introduce some hard to fix dependencies between different projects. And the last one is probably the result of those two that I mentioned before. So your inter-project library will be just growing by the way, right? If you create shared modules and then submodules, then actually you're just growing your inter-project library that you can share between the projects. If my talk was interesting to you, you can grab some reading. Of course, the main book on the market, The Clean Architecture from Uncle Bob. This is the great stuff, not only for IT guys, but also for game developers. There's also worth to note about this Microsoft.NET library. They have two great frameworks, the Managed Extensibility and Managed Add-in framework. These are great in terms of inspiration. They just do what I said, but on this high formal level, right? If you like videos, you can try with the Codemanship or Simon Brown from GoTo conference. He had a great talk about modular monoliths. And the modular design in C#, these are great starting points for me, let's say. Yeah, and that's it from me. If you have any questions, I probably assume that we will have some time for questions. Right? Okay, so thanks.
Thank you very much, Paweł. So guys, are there any questions? I see already someone raising their hands.
Thank you very much, and hello there. So I have a question because it seems to me that modularity in the game development is actually a natural thing to do in terms of moving the stuff between the titles. So this is a very good thing for reusability. But from the things that I've struggled with assembly definitions and Unity packages in the past is that they are quite difficult to manage. I mean, if we put a lot of modularity into the app, there is a lot of those files, and this in particular it's visible when we are using third-party packages that sometimes are also platform dependent because we resign from the main assembly file that is generated by Unity for us. So my question would be, do you have any tips of managing those files if there is plenty of them, along with the private packages? How do you store them for the inter-projects stuff?
This is the hard one, probably. Well, basically, if in terms of those external dependencies, like libraries made by different studios, we also stumbled upon some issues connected with assemblies. We also had to tweak some internal stuff to make it work. I think it's just communicating with those providers, right? In terms of your internal stuff, for now, we're just experiencing with different approaches. We have some submodules for the core stuff, let's say. And well, this works really fine in our pipeline because we have really experienced developers that they have no problems with submodules management and so on. So if your team is experienced, probably this is the best way to use it. But we have also some packages in our workflow, and mainly the main con of packages is that it's hard to set up for the first time a Unity project. You probably want to store those packages in some private repository, and you have to set up those SSH keys and so on, right? So basically, I think it's good to have some technical guy that is just dedicated for maintaining this stuff, and yeah, and helping those non-technical users that have problems with it. It's really hard to answer in just a few sentences, right? And so if you want, we can chat about it later.
Thank you. Any other questions? Okay.
Yeah. Hello. Thank you for your talk. I saw that you talk a little bit about MVC, but honestly, I have a few problems with such a pattern because it's like mostly called like MVC family and a lot of ways to cook in that stuff. But what do you think about how to use modular approach with ECS pattern, which is quite popular for now, like and data oriented and blah blah blah. Thing. So, but for me, it seems like quite tricky. Do you think about that?
To be honest, I had no experience with such big and corporate project connected with ECS, so I don't have any advice or experience about that. So it's hard to tell for me. But yeah, it has some similarities. Like it's really data oriented. Yes, so you can at least get those data related stuff. It's also kind of solving some part of the problems. In terms of view, my intuition, but it's of course my intuition, yes. I think that those job scope components they should be the main layer where you want to communicate with a view. So we have in our project, for example, we have signal bus, which allows us to bypass this formal dependency, right? We can just put something to the signal bus and just listen for it in any different place in the project. But for me, it can lead to some problems because in many places you send signal from place where you don't have enough information about the context. So in this case, in my private projects, I tend to use something different. I try to incorporate some managers. So if you have some dynamic collection of classes or some different entities, you usually want to have some manager that manages their life cycle, and of course, it's because it's managing their life cycle. It knows everything about the context, so it's a great way to introduce this communication level just using this manager. So all the stuff behind that should communicate to this manager, and this manager can communicate to the next level, in this case, the view level, right?
Okay, thank you. Next question.
Good day. I have a question regarding the growing number of assemblies and their effect on performance. For example, in our projects, we have hundreds of assemblies and we experience growing compilation times, IDE takes up more memory, and so on and so forth. How do you mitigate that, if you can?
How many assemblies do you have?
Sorry?
How many assemblies do you have?
Hundreds.
Okay, this is a big scale. I have no experience to answer that question, sorry.
Okay, thank you. There on the left, there was next person.
Hello, thank you for your talk. How much time do you spend writing unit tests, and how do you evaluate if it's worth to write unit tests or just write new features and test manually?
It depends on project. In my private projects, I tend to write unit tests right away, and it's hard to estimate how much time I spend on it because they just like in test-driven development, they just come with the main feature, right? In our main project, the Evolence team, we tend to introduce tests only for those stuff that is really complicated in terms of logic. For example, we don't care about view stuff because we have a dedicated team of manual testers for doing that. So there's probably no benefit of it, of writing some unit tests or integration tests on the view level. But in terms, for example, we have a gacha system or have some drop system. Automating that gives you such acceleration. You probably will have, you will need some, I don't know, a dedicated team of testers to just test one dropping feature for entire week to have some good results, right? So automating such stuff, I think, is the best candidate.
Okay, thank you. Next question. I saw there's okay.
Yeah, another question. So I saw you use inject attributes, so it looks like you're using some kind of third-party dependency injection stuff, or you have your own,
Yeah.
I don't know. So that means that you have a dependence of the third-party library for like something. And if you using packages, that's my case. I prefer using packages in Unity Package Manager. So we made some modules, but we also use third-party library. But Unity Package Manager can't deal with the sub-dependency of the Git repo of another module. So you need to manually install all of the dependencies on your project, so it's quite messy. Do you thought about your own package registry, or maybe you use some of free one? Because I'm trying to find any solution for that, and they just don't.
I think that in Unity 2018, there were some issues connected with dependencies, but right now, when we switched to 19 and 2021, we don't have such issues anymore, so maybe just updating Unity is the case for you. They should manage the sub-modules by design. Maybe there's some bug in your code. Well, maybe on the Unity side, right? But we are using Zenject in our projects, and if you're somehow forced to not to use, for example, you're writing some public library, you can simply create some abstract classes with abstract getters, right? And bypass that way. I know it's cumbersome, but yeah, should do the trick.
So does it correct that you use as a main approach for packages is just a Git repo and install it from Unity Package Manager?
Yeah, we store all those packages in a single repository in just different projects, but we have the same SSH key. Maybe that's the case. I don't know.
Okay, that's it. Thanks.
Thank you, Paweł, once again for amazing talk.